Hi everyone, welcome to Happy Math Hour, weekly interactive sessions for Math 1314 and Math 1324, presented by Ms. Yvette Chuka, Mr. Ruben Carzales, and Mr. Albert Isasi. Today's sessions are final exam reviews for both 1314 and 1324. This session is currently being recorded so that you may review it later on. For now, please mute your mics for the best sound experience. And without further ado, let's have our presenters up.
Hello, everyone. I am glad that you were able to meet us for our last TV Math Happy Hour for the semester. Um, for those of you who are here for Math 1324, please click on the link that is in the chat. It's the https tinyurl.com epcctv e2. So if you're here for the Math 1324, please go ahead and click on that link. Okay, so we'll give you a couple of seconds to go to the desired session or group. Very good. Again, welcome. So Ms. Chuka and I, we went ahead and created this final exam review. If you are all have questions, please feel free to ask. Again, we want to take advantage of this last day of happy hour. So if you have any questions, please feel free to ask. So we're going to go ahead and get started. Okay. So the first question that we want to review is finding x-intercepts and y-intercepts. Okay, and also applying symmetry to our equations. So the first question here says, again, it's copied directly from your homework. It says, find any intercepts and test for symmetry with respect to both axes and to the origin. So just to do a quick review, if we want to find the x-intercept, we would set y equal to 0. And if we want to find the y-intercept, we would set x equal to 0. So let's go ahead and do that. So for our first problem, for the first part, let's find the x-intercept. So we're going to let y equals 0 and solve for x. Okay. Right, so this is our equation. Y is equal to minus 2x plus 1. And we're going to set y equal to 0. This is going to give us y is equal to minus 2x plus 1. So we're going to solve. So the first thing we're going to do is we need to isolate the x, but we'll move everything that's furthest away from x first. Okay, so we're going to subtract 1 on both sides. And when we do that, the plus 1 minus 1 cancels. And 0 minus 1 gives us negative 1. Okay. The next thing we're going to do is we're going to divide both sides by a negative 2. And when we do that, again, negative 2 divided by negative 2 becomes 1, or you can think of it as cancels, leaving us just with the x. And then we have negative 1 divided by negative 2. We always want to simplify our fractions. A negative divided by a negative becomes a positive. So x is equal to 1/2. Okay. Now, when we put this information into the computer, again, they want us to answer our intercept as a point. Okay, so our x value we discovered and we solved, it was 1/2, and our y value was 0. Okay, all right. If there's no questions, let's go ahead and solve for the y-intercept. So to find the y-intercept, we are going to set x equal to 0 and solve for y. Okay, so our equation is y is equal to minus 2x plus 1. Replace x by 0. Now, yes, as Ms. Chuka stated, we don't have to put the parentheses, okay? We went ahead and put them here, but don't put them on the computer because they already supplying the parentheses for you, okay? So do not put the parentheses. Okay, so let's go ahead and solve for y. So we have minus 2 times 0 plus 1. So again, we are going to just follow the order of operations. So we're going to multiply -2 times 0, which is going to give us 0. 0 plus 1 will be y equals 1. And again, the answer needs to be as an ordered pair. Please don't put extra parentheses because the parentheses are already there. And our answer for the y-intercept is going to be 0, 1. Okay, so let's see. Can we apply axis of symmetry? Now, hopefully, being this is the end of the semester, we see that this is a line, right? This is a linear graph. It's a linear equation, and it's in the form of slope-intercept form. So because it's a line, okay, we can graph it to see if this graph has any symmetry. So does it have any symmetry? So the x-axis, it has x-axis symmetry, right? Based on our definitions, that if we have x, y, and we go from x to negative y, we can have x-axis symmetry. So replace the y with negative y and solve for y. Let's see if it has x-axis symmetry. Okay, so when we replace the y with a negative y, okay, divide both sides by a -1, we notice that the answer is not the original equation, right? The original equation was y is equal to -2x plus 1. So this has no x-axis symmetry, okay? Let's see if it has y-axis symmetry. Based on the rules for y-axis symmetry, if the xy has the same value of -xy, then it has y-axis symmetry. So let's go ahead and replace x with a -x and solve for y. Okay? So when we do this, we simplify, and we notice that the answer again is not the original equation. We have a positive again, 2x, and then a positive 1, and it's not -2x plus 1. So let's check for the last origin symmetry. For origin symmetry, if we replace the -x and the -y, let's see if we get the same equation. So when we do this, we simplify, and we're going to get y is equal to -2x minus 1. And again, we do not have the same equation. So for our answer, which I didn't put in, is it has no symmetry because it did not apply for any of our rules. We didn't get back the same equation. Any questions? Okay, yeah, let's keep on moving with our review. Let's look at this problem. It says, write the standard form of the equation of the circle with the given characteristics. Okay, so a recap, the equation for the standard form of a circle is given by x minus h squared plus y minus k squared is equal to r squared, where h and k indicates our center and r refers to the radius. Okay, so here in our case, our center is at -4, 2, so that means h is -4, and k is a positive 2. Our radius is going to be 2. So let's go ahead and plug them in to our equation. We have x minus 4 squared plus y minus 2 squared is equal to 2 squared. Okay, let's go ahead and simplify. A negative with a negative gives me a positive. So we have x plus 4 squared. And on this one, we didn't have to simplify. It's already simplified. Y minus 2 squared is equal to 4. Okay, so we did it. They wanted us to, write the standard form of the equation with these characteristics. So we have x plus 4 squared plus y minus 2 squared is equal to 4. Okay, any questions? Okay, let's move forward. Let's look at this equation problem. Write equations of the lines through the given point parallel and perpendicular to the given line. So to review parallel and perpendicular lines. Lines are parallel if they have the same slope. If they demonstrate that they have the same slope and different y-intercepts, then these two lines are parallel, okay? For it to be perpendicular, okay, it's a special case. I always like to say that they have to have an opposite slope, okay? And we'll go ahead and solve for this perpendicular slope. But before we can do that, in order for us to give the parallel and perpendicular to this given line, we need to find what the slope of this line is. Now, I can't tell just in the way it is right now what the slope is. So what I like to do is I like to convert this equation, which is in general form, is to convert it into slope-intercept form. That way I can see what the slope of this equation is, what this line is. Okay, so what I'm gonna do first is solve for y. Again, putting this equation into slope-intercept form. So here, what I did first is I subtracted a negative 8x on both sides, okay? And then I divided both sides by a negative 2, which after simplifying, okay, I have y is equal to negative 3/2 plus 4x. And hopefully we see here that we can identify now what the slope of this equation is, which is 4. Okay, this is my slope. My y-intercept is negative 3/2. So now that I have my slope, let's go ahead and solve for the perpendicular slope. So to get the perpendicular slope, or before we do the perpendicular slope, let's go ahead and just find the equation of the line that is parallel to this given slope. M is equal to 4. So in order for me to do that, I'm going to apply the point slope formula. The point slope formulas, it says that if you're given the slope and a point, you can use this equation. Y minus y1 equals m times x minus x1, where x1 and y1 is the point that you want your line to go through. So let's go ahead and substitute these values into this formula. Okay, so we have y minus 1 equals 4 times x minus 8. Okay, so the first thing we're going to do is we're going to distribute the 4 inside this parenthesis. So we get 4x, and 4 times a negative 8 gives me a negative 32. Okay, then the next thing that I'm going to do is I want to move or isolate the y, so I'm going to add 1 on both sides and simplify. Okay, so we have y equals 4x minus 32 plus 1, which will give me y equals 4x minus 31. And this line, we can see that it's parallel to our given line because, again, they both share the same slope, which is 4. And they have different y-intercepts. Our intercepts are different. Any questions? Okay. All right. Let's go ahead and find the perpendicular line given this information. So the first thing that we need to do is find the perpendicular slope. So what I like to do is first I like to convert the parallel slope into a fraction, make it 4/1. Okay. And then I take the reciprocal of that, which becomes 1/4, and then change the sign. So it was a positive, so my perpendicular slope is going to be negative 1/4. And that's why I like to say that it's the opposite slope, because we take the number, we take the reciprocal, and then we also change the sign. Okay, so again, we're going to apply the same equation, the point slope, now that we're having the slope and the point that we want to through. So let's go ahead and plug them in. What we have y minus 1 equals now our perpendicular slope, which is a negative 1/4 times x minus 8. We're going to distribute that negative 1/4, and this is going to give us negative 1/4x times a negative 8 times a negative 1/4. And we're going to, well, here, let's do the simplification first. A negative times a negative is a positive, and 8 divided by 4 is going to give me a positive 2. Now I can add 1 on both sides. It's going to give me negative 1/4 x plus 2 plus 1, which gives me 2 plus 1 is 3. So the equation of the perpendicular line to this given line is y equals negative 1/4 x plus 3. And what we were interested in is that it has this perpendicular slope, which is negative 1/4. Okay. Any questions? Okay, let's move on. All right. Find the following. Given we have two functions, f of x is equal to 9x plus 1, which we can see that this is a linear function. And then we have g of x. G of x is equal to x squared minus 4. And hopefully we can identify that we are dealing with a quadratic. Again, I knew that this one was a linear because the exponent on the x here, change my color here, here was a 1, okay? And on this one is a 2. So this is my indicators of what I'm working with. So let's go ahead and do this operation. They want us to add function f with function g, okay? So the syntax for this addition of function f with function g, you can think of it as just straightforward, adding function f plus function g. So function f is 9x plus 1 here in red, plus function g, which is x squared minus 4. So we're going to simplify by combining our like terms, and we also like to put it in standard form, or where the highest exponent in our leading coefficient has the highest exponent, and we write our variables in decreasing order. Okay, so we only have one thing that has an x squared, so that one goes first. Okay, we have just one variable that has an x in it, that's the 9x, it's a positive, so that goes next. But then we have two like terms, which we have two constants. We have a plus 1 and a minus 4. So a plus 1 with a minus 4 is going to give me a negative 3. And this is the addition of these two functions. That will linear with a quadratic, it's going to give me x squared plus 9x minus 3. Any questions? Okay. All right, let's do another one. Let's do this. Let's go ahead and subtract function f with function g. And the syntax for this is f minus g of x. And again, we will do this straightforward. F minus g is just subtracting function f with function g. So again, function f is 9x plus 1. But because now I have a subtraction and I have a polynomial, I went ahead and put parentheses so I can distribute this subtraction symbol or negative symbol if you want to think about it. Okay, so don't forget our parentheses. We have parentheses x squared minus 4, which is our function g. So to simplify, we first have to distribute this negative 1. You can think of it as a negative 1. A negative times a positive x squared is going to give me a negative x squared. A negative times a negative is a positive, and it's going to be positive 4. And we're going to do the same thing as before. Let's combine our like terms. So we want to pick the highest exponent variable, which is this x squared, but it's a negative x squared, so that one goes first. We don't have anything else with the x, so that goes next. It's a 9x. But then again, we have two constants again. We have a plus 1 and a plus 4. So we add these two constants. We have plus 1 plus 4 is a plus 5. So function f minus function g equals negative x squared plus 9x plus 5. Okay? All right, let's try another example. Let's try this one. Ooh, a little bit harder. This is saying that we want to multiply function f with function g. Again, there's no symbol here for multiplication, but when two things are next to each other, this indicates multiplication. Again, the syntax and simplification of multiplying function f with function g is precisely just that, multiplying function f with function g. So my function f is 9x plus 1, and because I'm going to be multiplying, I'm going to go ahead and put parentheses on this one, times my function g, which is x squared minus 4. So now all I have to do now is FOIL, right? I need to distribute the 9x to all of the elements in the other function. So 9x times the x squared gives me 9x cubed. Again, we're going to add the exponents when we're multiplying two elements that have the same base. We'll add the exponents. 9x times a negative 4 is going to give me a negative 36x. Okay, then I do it again with the plus 1. The plus 1 needs to be multiplied with this term and with this term. So plus 1 times x squared is just going to give me x squared. Plus 1 times a negative 4 is going to give me a negative 4. And then again, all I have to do is combine my like terms. Again, I look at the highest exponent. So my highest exponent element is this one, 9x cubed. So that one goes first. And then I don't have any more x cubes, but then I go to the next one down. I have an x squared and I don't have any other x squared, so that one goes next. I have an x squared. Then I look for the anything that has an x. I only have one element that has an x, is negative 36x. And my last element is my constant, which is just a negative 4. So the functions f times g is going to result in 9x cubed plus x squared minus 36 minus 4. Any questions? All right, let's do the harder one. Let's do the dividing of two functions, okay? So we want to divide function f with function g. And I say it's the harder one because I know that for some students, they get scared when we're dealing with fractions. And I hope by now you see just fractions are just number. They're easy to work with, okay? So again, dividing function f with function g is basically just this. Dividing function f is my numerator, divided by function g is my denominator. And let's substitute. Function f is 9x plus 1. Function g is x squared minus 4. And then we look at this equation. Can we simplify it? Is there something that we can simplify? We can't, from the denominator, we can't factor out an x because this element doesn't have an x. We factor out a 4 because this x squared doesn't have a 4. And same with my numerator. This element here only has an x, but the 1 doesn't have an x. So our answer for the division of function f with function g is just precisely this. 9x plus 1 divided by x squared minus 4. Any questions? Okay. All right. There will be some times that you'll have to simplify, okay, but not in this case. All right. Let's go ahead and move forward. So let's ask on your homework, and this is comes directly from your homework. Your homework, after they tell you to do these basic operations, then they ask you to find the domain of function f divided by function g. So because this is a fraction, we're going to have a restriction, and the restriction for all fractions is that we never want the denominator to ever be a value equal to 0, because if we have a number of 0 as a denominator for a fraction, we all know that this is undefined. So let's see, will x squared minus 4 ever become 0? So to do that, we can set it equal to 0 to see if we have any restrictions. So let's solve for x. So we're going to add both sides by 4. It's going to give me x squared is equal to 4. And then I'm going to take the square root of both sides. So the square root of x squared, the square root with the square cancels. And it's going to give me the square root of 4. The square root of 4 is going to give me a value of positive 2 and negative 2. So then I know that when I plug in a positive 2 or negative 2 to the denominator, for the x value of the denominator, I'm going to get a 0. So just so you can check, 2 squared, that's 4. 4 minus 4 is 0. And if it was a negative 2 squared is a positive 4 again. And positive 4 minus 4 is also 0. So we never want to have our x value be either a positive 2 or negative 2. So in interval notation, the way the computer wanted you to answer this question is we always write our intervals from left to right. So going from the left side is from negative infinity. The first value that we can't use is negative 2. And we also put parentheses for these because the infinity is not a number, right? Infinity goes on forever. So whenever we have a number that we don't want to include or we don't know and never stops, we're going to use this notation, parentheses. So the -2, we don't want to use a -2, so we're going to use the parentheses. This U looking symbol is called a union, so or the word and. So we can use from -15 to -2, not including -2, and the next part of the interval is starting from -2, not including -2, to +2, and again, close my parentheses because I cannot use a +2. Then we have and starting from the right of 2, so we start at 2, again, parentheses, not including 2, but we can use all of the values after that, so that's until positive infinity, okay? So our domain for f divided by g is given by this interval. Okay. Any questions? All right, let's move forward. Let's do some more math, okay? So let's see. Does the function have an inverse? So when you are checking to see if a function has an inverse, just like you had checked before, if a function was a function, you did the um, um, vertical line test. Now we can use the horizontal line test to see if a function has an inverse. So for instance, in this graph here, if I have this line in blue, okay, if I want to see if this line has an inverse, I will perform my horizontal line test. And again, this is an imaginary horizontal line that I can traverse through the whole graph, okay? And if this horizontal line only crosses my graph one time, then that means that it has an inverse, okay? All right, so let's look at this function. Determine whether the function has an inverse. So we are looking at a square root function. Again, this little piece of information here says that we want x to be greater than or equal to 8. Okay, now why is that? Why is it that x has to be bigger or equal to 8? So what would happen if x was 7? Let's say that if x was 7. If we plug in 7 here, what 7 minus 8 is going to give us a square root of -1. And I know when we first started doing math 13-14, we saw that a square root of -1 is undefined, right? But later on, we discovered that we can make those into imaginary numbers, but that's not a real number. So that's the reason why they give us this piece of information, because we only want to deal with real numbers. So that's what this notation means, that x has to be greater than or equal to 8. All right, so let's see. Does this function have an inverse? So what I would do is we want to apply the vertical and horizontal line test to first again to find out if it has a function. This for the vertical line test, and then do the horizontal line test to see if it has an inverse function. So let's go ahead and do this. So to do this, we're going to replace f of x with y first to make it into an equation. And then we're going to interchange our x and y values, okay? So if we don't want a graph and we want to find out if the function has an inverse, we can swap the variables and solve for y again. And if we are able to do it, we can find our inverse function, okay? So let's go ahead and do this. So we have x is equal to the square root of y minus 8. So again, I'm going to solve for y, so I'm going to square both sides. So the square root with the square will cancel each other out, okay? So it's going to leave me with x squared on the left, and on the right, we just have y minus 8. We're going to add 8 on both sides. So this is going to give us y is equal to x squared plus 8. Okay. Again, you don't ever wanted to input this on the computer, because again, this is an equation that we use to solve for the inverse function. So the notation for the inverse is given by f to the exponent -1. This symbol here means it's the inverse function. Okay. So the inverse of f of x is equal to the square root of x minus 8 is x squared plus 8. Okay. Now, we can check this, but if you have any questions. So let's go ahead and move on to this next example. It says, sketch the graph of the function by applying the leading coefficient test, finding the real zeros of the polynomial, plotting sufficient solution points, and drawing a continuous curve through the points. So I have this function, and I can see that it's a square function, right? And the graph is going to be a parabola. So what we have, g of x squared, g of x is equal to negative x squared plus 12x minus 32. So we have this multiple choice, says apply the leading coefficient test, okay? So if we want to apply the leading coefficient test, okay, these are the rules, okay? So for the function of x squared, it's going to rise from the right and rise from the left. Yes, since my leading coefficient is a positive value, and since my exponent is even, you can think of it that it's going to rise both from the left and from the right, okay? If my leading coefficient is negative, then that means my graph is pointing down on both sides, that it falls to the right and to the left, both from left and right, okay? These are the definitions for a cube. If my leading coefficient is a positive for a cube function, okay, it rises from the right, but it falls from the left. I always like to think of also the cubes. You know, if my number is positive, my leading coefficient is positive, it's like I'm continuously rising. As I read my graph from left to right, I'm constantly going up, okay? Inversely, you know, the function negative x cubed, we know that the graph, if my leading coefficient is a negative number, is going to fall on the right and it raises from the left. But again, I like to think of it, if I'm reading the graph from left to right, it's always going down, right? It's going down. So these are my rules. So if I look at this function, my leading coefficient is a -1. So what this means is my function is going to be applied to this rule, that when my leading coefficient is a negative number, it's going to fall from the right and fall from the left. So which is the one that we have to select? So the correct choice is this. The graph of the function falls to the left and falls to the right. Yes? Awesome. All right. Any questions? Okay. All right, let's move forward to continue answering the questions. B says, find the real zeros of the polynomial. Enter your answers as a comma-separated list. Okay, so they already telling us that we're solving for the intercepts, the x-intercepts, and they give us x equals to 0. So let's go ahead and find all the zeros. Okay, so the first thing that I want to do is to find the x-intercepts. Again, I'm going to set y equal to 0, and in my problem, g of x is had replaced y. So we have 0 is equal to negative x squared plus 12x minus 32. Okay, my way of always solving for the x-intercepts when we have polynomials, always factoring. It's always my first choice. So I can factor x squared minus 12x plus 32 by x minus 8 times x minus 4. And if you don't see it, what we can also do is separate this, because we have a product that equals to 0. So that means either this value has to be 0 or this value has to be 0. So let's find out. X minus 8 is equal to 0, or x minus 4 is equal to 0. So when I solve for x here, I add 8 on both sides. It's going to be x is equal to 8. When I add 4 here on both sides, x is equal to 4. So the solution for this is going to be 4 comma 8. Yes? So that's the way we put in our zeros. Now let's go ahead and find the y-intercept, the easy one. To find the y-intercept, we set x equal to 0. Everywhere we see x, we're going to plug in 0. So we did that here. Y equals 0 squared is 0 times a negative is just 0. 12 times 0, that's 0. 0 plus 0, that's 0. And 0 minus 32 is going to give me negative 32. Now, if they had asked us to find the vertex of this graph, again, we could have graphed it, but we could also use our formula to find the vertex. And the vertex, when given a quadratic, is given by this formula. Just keep in mind that this in standard form is ax squared plus bx plus c. Okay, so here we have negative b over 2a. So in our case, b is 12. Okay, and a is 1 or negative 1, right? So since we don't have a number, but we have this negative symbol, we have negative 1. So let's plug it in to find the x value of the vertex. The first one is the x, and this is the y. To get the y, again, we're going to, once we get our value for x, we're just going to plug that in into our function to get our y value. So let's get our x first. So again, b is 12, so we have 12 divided by 2 times a negative 1, because that's what our a is, and it was a negative symbol. So we have 2 times a negative 1 is a negative 2. A negative divided by a negative is a positive, and 12 divided by 2 is 6. So the x value of this, or the vertex of the x value of this function, is 6. So to get the y value, I'm going to plug it into my function. So everywhere I see x, I'm going to plug in 6. So we have 6 squared is going to be 36. Times a negative 1 is going to be a negative 36. 12 times 6 is 72. So negative 36 plus 72 minus 32 is going to give me 4. So the vertex of this function is going to be 6, 4. Okay. And again, the end behavior, this graph falls from the right and falls from the left. Okay. Again, and if we were graphing it, we can prove our solution. This has x-intercepts at 4 and at 8. Okay. And our y-intercept we can't see because our graph only goes up to negative 15, but it's somewhere way down here, right? Our graph is going to cross somewhere down here. Okay. Any questions on this example? All right, let's go ahead and keep on moving forward. Find the rational zeros of the polynomial function given f of x is equal to x cubed plus x squared minus 9x minus 9. So it says the rational zeros. So the rational zeros is this fraction, right? And we have a formula to find the rational zeros. And to do that, we have to get the factors of the constant divided by the factors of the leading coefficient. Okay, so again, my constant in this case is 9. And again, I'm not worried about the sign because I'm going to look at both of them. I'm going to look at the positive and negative values. So I'm not interested in the sign. I'm just interested in the value. So the value of my constant is 9. The value of my leading coefficient is 1. So I see that the factors are 9 are 1, 3, and 9. The factors of 1, of course, it's just only 1. So the possible rational zeros that this function has is this division. So we do this. We work each one at a time. A positive 1 divided by a positive 1, well, that's going to give me a positive 1. A positive 1 divided by a negative 1, it's going to give me a negative 1. Now, I can do backwards too. A negative 1 divided by a negative 1 is a positive 1, but we never want to write duplicates. So since we already have it there, we don't have to rewrite it. And negative 1 divided by a positive 1 is going to give me a negative 1, but I already had it, so I don't have to write it again. And then I follow the same pattern again. Then I do 3 divided by 1, or positive and negative 3 divided by a positive negative 1. Again, a positive 3 divided by a positive 1 is going to give me a positive 3. A positive 3 with a negative 1 is going to give me a negative 3. And then I can also switch it again. A negative 3 divided by a positive 1 is a negative 3, but I don't have to rewrite it because it's already there. And a negative 3 with a negative 1 is, again, a positive 3, so I don't have to rewrite that. And then I do the last one. I divide positive and negative 9 divided by a positive negative 1. And again, the two factors, I'm going to get negative divided by negative is a positive, so we have 9. A negative with a positive gives me a negative 9. So the possible rational zeros using the zero test, okay, is the list. And it doesn't have to be in order, but it's always good, especially when we're doing computer, to combine them. That way we don't miss one, because it's very easy to miss one, okay? All right. Now, what we can do is we want to simplify, because we have no formula to find the x-intercepts of a cube function. So what I would like to do is use synthetic division to simplify this cube. And if I have it into a quadratic, again, I can either factor it to find the last two x-intercepts, or I can use my quadratic equation. So let's go ahead and start simplifying this cube function. And let's use synthetic division. And I'm going to use these possible zeros that I just discovered to help me simplify my cube function. So I'm going to start with this one. So again, synthetic division, we only write the coefficients of the polynomial, but we also got to make sure that my polynomial is in standard form, or that is in decreasing order, that the highest exponent is first and each variable afterward is one less than the one before. So again, this polynomial is in order. We have a 3, 2, 1, and constant. So my leading my coefficients are 1, 1, negative 9, and oops, this is supposed to be negative 9 here as well, okay? So let's go ahead and do synthetic division. So the first step of synthetic division is we bring down this 1, okay? So we multiply. 1 times 1 is 1, and 1 plus 1 is 2. So we add, right? The second step is once we multiply the 1 here, we place it in the second column, and we add. Then we do it again. 1 times 2 is going to give me 2, and negative 9 plus 2 is negative 7. Let's do it one more time. 1 times a negative 7 is going to give me a negative 7, but again, this really should have been a negative here. So negative 9 with a negative 7, this is going to give me a negative 16. So regardless, a 1 is not a factor of this polynomial, because in order for me to have gone, or for 1 to have been a factor, we had to use our zero property. Yes, and Yvette's all sad about that. We didn't get a 1, right? But if our remainder, our last value, is 0, then that means that the value that we use is a factor of this polynomial. Again, this comes from the factor of x minus 1, right? Okay, so let's go ahead and try another possibility. So 1 is not a 0, okay? So let's do it again. Again, we'll fix the negative 9 at the end, okay? So we're going to try negative 1 now, okay? So again, we bring down our 1 first, and then we multiply. Negative 1 times 1 is a negative 1. We add. 1 minus 1 gives me 0. And I'm going to do it again. I'm going to multiply negative 1 times 0. Negative 1 times 0, that's 0. And I'm going to add. Negative 9 plus 0 is a negative 9. Now I'm going to multiply negative 9 with the 9. And again, we had forgotten the negative symbol. This had to be a negative right here. So negative 9 plus a positive 9 is 0. Awesome. Right now we're happy, right? I hope Yvette is happy now. So because our remainder was 0, we have discovered that x is a factor. But the whole reason why I wanted to do this is because now that I have one of the x-intercepts, which is the negative 1, I can convert this into a quadratic. This converted as an equation, okay, again, x equals -1 is one of my zeros, and big smile here. But now I can use this remainder or this quotient to find my two remaining zeros. And I know I was going to have 3 zeros because this was a cube function, right? So I possibly could have had up to 3 zeros. So again, we have x squared minus 9. So this one I think is fairly easy. So what we can do is set it equal to 0 to find our remaining zeros. So let's do that. Let's get our quotient and set it equal to 0 to find our remaining zeros. So we have x squared minus 9 is equal to 0. So the first thing I'm going to do is I'm going to add 9 on both sides. So -9 plus 9 cancels. 0 plus 9 is 9, giving me x squared is equal to 9. I'm going to take the square root of both sides. And when I do that, okay, the square root will cancel with the square, and we're going to get this positive or negative square root of 9. So these cancel, giving me just x, and the square root of 9 is positive or -3. And we have found all our zeros. We have x is equal to -1, x is equal to -3, x is equal to 3. Okay. Again, we use several things to solve for our zeros in this polynomial. We first use our possible rational zero test to find the possible zeros. We use synthetic division to simplify the polynomial into something more manageable. Okay. All right. So again, our factors, if we wanted to write this, because your homework does ask you to list the factors of the polynomial. So again, to get the factors, I would just add 1 on both sides. So we have the x plus 1, add 3 on both sides. We have a x plus 3, subtract 3 on both sides. We have x minus 3. So the factors for these are x plus 1, x plus 3, x minus 3. So we can go ahead and graph and plot our zeros to do this curve. Again, the end behavior, because again, the leading coefficient here is positive, so that means that it's going to fall on the left and rise from the right. Okay, we can put some more values to get a more accurate graph. So in my case, I picked 2 and 1 to get a better feel for the behavior of this graph. So when I plug my values in, I can better graph my function. Okay, any questions? All right, let's move forward. Okay, let's look at this other example. Again, this is a copy just from your assignments from WebAssign. Okay, it says use the given zeros to find all the zeros of the function. So they give me a complex 0, okay, and it's complex because we have the symbol I here. This means that we're dealing with an imaginary number or a complex number. And our function again is a cube function. We have x cubed minus 12x squared plus 52x minus 80. I'm going to apply the same process that I did before. I want to simplify this cube to find the zeros. So I'm going to use synthetic division again to simplify this cube function. Again, it's already in order, so I don't have to worry about the order. I have a 3, 2, 1 constant. So let me grab my coefficients. I have 1, -12, positive 52, -80. Okay, so my 0 is 4 plus 2i. So let's go ahead and apply synthetic division. I bring down the 1. So 4 plus 2i times 1 is just going to give me 4 plus 2i. Okay, when I add the -12, this -12 doesn't have a complex part, it's just a real number. So I just add the real with real. There's no imaginary. You can think of it, this had a plus 0i. Okay, so -12 plus 4 is a -8. And then again, 0i plus 2i is a 2i. Okay, I'm going to do it again. This one's a little bit more challenging because I have to do FOIL. Okay, so when I multiply 4 plus 2i times a -8 plus 2i, okay, we have 4 times a -8 gives me the negative 32. Um, and the 4 times the 2i gives me the 8i. And then we have 2i times the negative 8 gives me the negative 16i. And then 2i plus a positive 2i gives me the 4i squared. Okay. Now we can simplify this. We know that um, I squared is equal to negative 1. Okay. So negative 1 times 4 is a negative 4. We can combine it with this other constant, negative 2, is going to give us a negative 36. And then 8i minus 16i, we know we can combine that into a negative 16i. Okay. So here it is. Combining our constants, we got negative 36 minus 8i. We're going to add it to the real part again. 52 minus 36 is going to give me the 16, positive 16, and then we have the negative 8i. We're going to do the same thing, multiply these two complex numbers. We end up with 64 minus 16i squared. Again, I squared is a negative 1. So this gives me a positive 16, and 64 plus 16 is going to give me an 80, and then negative 80 plus 80 is 0. Awesome. So we found that we have um, a 0 with the 4 plus 2i. Okay, then we have our quotient. Our quotient is the 1 is just the x squared plus negative 8 plus 2ix plus 16 minus 8i. We can simplify this, okay, by go ahead and applying the synthetic division again. So we can simplify. Since we're dealing with complex numbers, let's go ahead and continue practicing synthetic division. So um, I'm going to go through it fairly quickly. Again, we're running a little bit of time, and I think we have the idea on this one, right? So when we multiply again, we are left with the remainder 0 again, which leaves us with the quotient just x minus 4. And on this one, we can find easily that our other x-intercept is x equals 4, okay? All right, so I have about 8 minutes. Let's see if we can get in another example here. Let's do this one. This one is good. We have this rational function. It's a rational function because we're dealing with a fraction, 1 over x plus 3. Again, state the domain. We never want the domain to be equal to 0. So here we can solve for set x plus 3 equal to 0, and we can find that if x is equal to a negative 3 or a positive 3, we will get zeros, okay? Now, so we can identify all the intercepts. Again, we set x equal to 0, we find our y-intercept, and by setting y equal to 0, we find our x-intercepts, okay? There are several cases to find the vertical and horizontal asymptotes, and we'll go ahead and cover those right now. We'll go through those rules, okay? So the first one, let's state the domain. So we know that this value x can never be a negative 3 because x is a negative 3. We get 0 on here. So the answer for the domain of the function is all real numbers except for x cannot be negative 3. So it's this last one. Okay. All right. And I talked about it, and I want to go quickly so we can finish this problem out, this last problem, okay? So stop me if anybody has any questions. If I'm going too fast, please stop me, okay? All right, so we realize that all real numbers of x except for negative 3 is our domain, okay? All right, so let's first find the x-intercept. So to find the x-intercept, we're gonna set, again, y equal to 0 and solve for x. So again, our function was a symbol that replaced our y value, so we change it. 0 is equal to 1 plus x plus 3. If we multiply by x plus 3 on both sides, okay, 0 times x plus 3 is 0, and on the right side we get 1. So this is a false statement. 0 does not equal 1. So what this means, it has no x-intercept, that our graph does not cross the x-axis. So on your computer, you would type in does not exist, okay? Let's go ahead and find our y-intercepts. So let's set x equal to 0. Everywhere we see x, we're going to plug in 0. So we have 1x, we have 0. 0 plus 3 is 3. So our y-intercept is 1/3, right? So y equals 1/3. So in as an ordered pair, when x is equal to 0, y is equal to 1/3. Okay. Now, but let's get to the good stuff. Finding vertical or horizontal asymptotes. So let's start with first the vertical asymptote. Okay. So to find the vertical asymptote, um, what we can see is that if there was a restriction on our domain, we can find our vertical asymptote. Okay, so here we go back to our function. Oh, let me pause here. We do find our domain. Finding our domain gives us our vertical asymptote. But before we also do that, it's very important that our rational function is simplified. Yes, that both my numerator and denominator are both in its simplest form, and it is, right? One, I cannot factor anything else, and x plus 3 is already factored. It's already simplified. Yes. So again, when we set our denominator equal to 0 on the bottom, we had discovered that this was our restriction on our domain. So because it was our restriction on our domain, it is also our vertical asymptote. This means that x equals -3 is an imaginary vertical line that the graph cannot touch or cross. Okay, so this is my vertical asymptote. And again, you find it by finding the restriction on the function. Okay, now for the horizontal asymptote, okay, there's three different cases. Okay, so the first case is if the degree of the numerator is smaller than the degree of the denominator, we have a horizontal asymptote at y equals 0. Second case, if the degree of the numerator is equal to the degree of the denominator, then we have a horizontal asymptote by this fraction. We divide the leading coefficient of the numerator by the leading coefficient of the denominator. Okay? And the last case, if the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. Usually in this case, if this happens, what we have is a slant asymptote. Okay, if the degree of the numerator is larger than the degree of the denominator, we're going to end up with a slant asymptote. So let's go back to our function, and we can look at it this way. Here on this one, we have x equals to 0. Okay, anything to the 0 power gives us 1, and we have x to the 1, right? Because this is the highest degree. The highest degree here is 1. So here you can see that the degree of the numerator is much smaller, smaller than the degree of the denominator. So hence, I have a horizontal asymptote at y equals 0 from my definition of cases for my horizontal asymptote. So we can graph them, right? So these are all help indicators for us to graph our rational function. We have this imaginary vertical line that we cannot cross, and we have this imaginary horizontal line that we cannot cross. Okay. Now, what we can do is we can also, once we have all this information, we can plot additional points to make our graph a little smoother. Again, I picked these 2 points, -2 and 2, to see the behavior around this vertical line, to see how my graph should look like. Okay, and I solved it. Again, I can plot these points to get a better graph, to get the smooth graph. And again, based on my knowledge of asymptotes, my graph comes very, very close to this horizontal line, but never crosses it. And then it comes very, very close to this vertical line, but it never crosses it. Then we jump. This graph is from going up to infinity, but never crosses the line. Then as it gets close to this horizontal line, again, it crosses one of the points that we solved, but it never crosses this line. Okay, so again, I think this was the last question that I have time for. I've got less than a minute. Get it on your homework. It was a multiple choice to find the graph. So now that we graphed it, let's see which one is our answer. So on this one here we have -5. So and we know it can't be these two. These we can check them off. So it's between these two. But if you see our graph does not cross the um, x-axis here, right? So our answer here for our graph has to be what I would think A, right? A is our answer. This is A, B, C. Our answer is A. Okay. Again, I'd like to thank all of you for joining us this last day of review for your final. I wish you the best of luck. Please study, study, study your previous exams, study your homeworks, get ready for those finals next week. You're all going to do awesome. Okay. Hope all of you get good grades on your classes. Thank you so much for joining us.
Thank you, everybody, for joining us these last 15 weeks. It's been an honor to be able to do this every Friday. And thank you to the staff as well, who's in the room helping us with the messages and stuff.
Yes, a big applause to them, all the people that work behind the computer. Um, we like to really thank you all for all your help.
Alrighty, thank you, Mr. Carrizales and Ms. Chuca, for presenting today. I would like to thank also the audience for coming and being such a wonderful audience. We hope to see you guys soon. Good luck on your finals. I'll be turning off the recording.